Let's take a theorem here. If A is a m by n matrix, then n is equal to rank of A plus the nullity of A. I wrote down the previous example that we did here, so when I reference to general idea, I can show you the example that we did here. So let us start the proof. So as you remember, we reduced this matrix to find the rank. Let R be the rank of matrix A. Without loss of generality, assume we have the identity matrix created on the upper left side of matrix B. It's called matrix B, which is the reduced form of matrix A. Let us assume IR is the identity matrix formed on the upper left corner of B. And again, B is the reduced row echelon form of A. And since it has two non-zero rows, the rank is, as you remember, is 2. This is a previous example. Just writing this side by side, so when I reference, you can imagine and check what we are doing. So now think about it this way. The 0 rows of B, it doesn't contribute to the solution. Note that. This 0 row, we can add S, because if we expand this matrix, we might end up with more 0 rows. Does not contribute to the solution. So we can discard this. So we can discard them and form a R by N matrix that we call B prime. B prime is the augmented matrix, including identity matrix and C. C is the matrix with n minus R columns corresponding to the rest of the variables, x sub R plus 1, x sub R plus 2, and x sub n. So we can write the solution this way. x1 plus c sub 1, 1, x sub R plus 1 plus c sub 1 and 2, x R plus 2 plus the rest of the elements, c sub 1 and n minus R, x sub n equal to 0. Then we have x2. So just take a look at this. This guy is 0. So you don't have any x1 in the second row here. You get x2 plus c sub 2 and 1, x sub R plus 1 plus c 2 and 2, x sub R plus 2 plus the rest of the elements, plus c sub 2 and n minus R, xn is equal to 0, and you can continue this process. And finally, you get your XR plus C sub R1, X sub R plus 1 plus C. Here, now you have R and 2, X sub R plus 2 plus the rest of the elements, CR and N minus R, X, and equal to 0. So we are reducing the original system to this system. Very good. If you try to solve this, remember our goal is to find the solution. Solving for the first are variables in terms of the last n minus r. Variables give us n minus r vectors. So the solution space has n minus r dimension. So basically we have n minus, I'll move this up a little bit, rank of A. But what we try to find, we try to find the dimension of the null space. So the nullity of A is n minus rank of A. So basically n is equal to rank of A plus nullity of A. So to understand proof, always go over one simple example so you understand the behavior, and then generalize the idea to having more rows and more columns. So basically we're generalizing this system AX equal to 0, a more general form.